Right, members, welcome back. In this video, we are going to look at how to solve. We are going to look at how to solve exact differential equations. Solving exact differential equations. That's what we are saying here. Now, after having known how to test for exactness and after having confirmed whether the equation is exact or inexact, we go ahead to look at how these equations can be solved. Yeah. So without wasting time, I'm going to use examples from the previous video and example. Let's say solve the following. The is. Part A, we're going to look at y plus x dy dx is equal to 5. Then B, 2xy cubed plus 3x squared y squared dy dx is equals to cos x. We are beginning with this, and the fact that we have already tested that they are exact, I will not go back to test. Yeah, so I'll begin from the part of solving. But the first thing is to first show whether they are exact or not. Now, for this case, we need to know what we call a main function. Before you start on working on this question, after having tested for exactness, you need to know what an exact or what a main function in this expression is. Now, I need first to notify and say that the main function that we shall be using, the main function is equal to the integral of b. Which integral of b is the coefficient of the y, yeah, with respect to y, with respect to y. Now, meaning that after having tested for exactness, your equation was in this form. It was in the form y minus 5 dx, yeah, plus x dy is equal to 0. So for us, we say that the main function is equal to the integral of b, meaning, and we had said that our a, for this case, our a xy was equal to y minus 5, implying that our b xy is equal to the coefficient of dy, which is x. So x. Now, we are saying that the main function is equal to the integral of b. Now, what we do here, you come and say that the main function is equal to the integral of b, which b is x. So we shall say x dy. Yeah. And that should be equal to, because another thing we should know that after having understood that the equation is exact, yeah, it means that the terms on the left-hand side, are a result of derivative of the main function. So in other words, this one should be equaling to cos x. Not 5, sorry, for this case, to 5. Yeah. So after equating this to 5, now we go to integrate this. When you integrate this, you get xy. Yeah. We shall say xy is equal to 5. Sorry. The main function itself is the main function is the integral of b. So the integral of b is xy. That is our main function. Now, we are saying that the terms on the left-hand side are as a result of the derivative of the main function, meaning now it means that the derivative of the main function, that is d dx, of xy should be equal to 5, the right-hand side. You must equate to the right-hand side. So d dx of xy is equal to 5. Now, you come in the next step, you say d dx of xy is equal to 5. Now you integrate both sides. We shall integrate. Sorry. My pen is rushing than me. So we have d dx xy is equal to 5. We integrate both sides. We shall integrate here and we integrate here. Yeah. So with respect to x. Now when you integrate the derivative, you get that very function. So when we integrate the derivative of xy, we get xy. So xy is equal to, when you integrate 5, you get 5x. Yeah, because you're integrating with respect to x, so you get 5x plus a constant of integration. And this will be our final answer. But it all begins from testing for exactness. The moment I do for you this, you're going to get what exactly I'm trying to do. So let me solve the second one. B, we had also tested for exactness. That is where you're supposed to start from. Test for exactness, then carry on. Yeah. If it is not exact, I'm going to show you how inexact equations are solved. So for this case, we have 2xy cubed plus 3x squared y squared dy dx is equal to cos x. Yeah, we had already seen that it is exact. So here, solve this solution, just for exactness, which we had done. Just for exactness. After testing for exactness, now get the other general form of the equation, which we had. And after testing for exactness, we found that it is axy is equal to 2xy cubed minus cos x. Then we saw that b xy was 3x squared y squared. So our main function is the integral of b. So we need to get our main function. Our main function would be equaling to the integral of b, yeah, with respect to y. So it is 3x squared y squared, yeah, dy. That will give us our main function. So our main function will be, since we are integrating with respect to y, it means that y will be y cubed over 3. So we shall have x squared y cubed. This is our main function. It implies that the derivative of our main function, x squared y cubed, is equal to the right-hand side, which is cos x. Yeah, that is what you should know. The derivative of the main function should be equaling to the terms on the right-hand side, implying that if we integrate both sides, we shall have the integral of d dx x squared y cubed dx is equal to the integral of cos x dx. So when you integrate the derivative, you get that very function. So we shall have x squared y cubed is equal to, when you integrate cos, you get sine. So it will be sine x plus a constant of integration. And that is the final answer. That is the final answer. That is our final answer. Then now, after doing this, now let us do some other questions where we need first test exactness, then we continue. Number 2. Solve the following equations. A, x squared dy dx plus 2xy is equal to 1. B, x squared cos u du dx plus 2x sin u is equals to 1 over x. C, e to the power y plus xe y dy dx is equal to 2. Then d, t squared over x dx dt plus 2t ln x is equals to 3 cos t. Of course, I can't do all. I will do like 2, then you do the rest. However, practice will make perfect in this. Now, what we are going to do here, we are going to begin with this first one. I test for exactness, then we continue. So, solution. We are having x squared dy dx plus 2xy is equals to 1. Now, for this case, we need to first test for exactness. And how do you test for the exactness? To test for exactness, we need to first bring this one this side. So we shall have x squared dy dx, yeah, plus 2xy minus 1 is equal to 0. Then we shall have x squared dy plus x squared dy plus 2xy minus 1 dx is equal to 0. So now, for this case, if you have the ones of dx and the ones of dy, yeah, you can move on. So this is B and this is A. It means that our A, xy is 2, xy minus 1, and our B, xy is equals to x squared. So you look for curl A, curl A, curl Y, curl A, curl Y, it means that this will be 2x, and curl B, curl X, it will be 2x, implying that the differential equation is the exact. Yeah, now, being exact, now we can get the main function. We said that the main function is equal to the integral of b with respect to y. So it will be x squared dy. So when you integrate x squared, you get x squared y, because we're integrating with respect to y. Then we say that the derivative implies that the derivative ddx of the main function, which is x squared y, should be equal to the right hand side, which is 1. Yeah. Then it implies that when you integrate ddx x squared y dx is equal to the integral of 1 dx. So when you integrate the derivative, you get that very function, x squared y is equal to, when you integrate 1, you get x and plus a constant of integration, as simple as that. So in case the function given is really exact, it takes you little time to get the answer. So the main thing is always to first test for the exactness. Yeah. Okay, so let me do that of E. Yeah, let me do that of E, then maybe you can do the rest. B, we are having e to the power y plus x e y dy dx is equal to 2. So of course, for you to know that this equation is exact, you are going to see the unique feature with the inexact equations. Yeah. So for you to show that here they are, for you to show that they're exact, first bring this on this side. So we shall have e y minus 2, then plus x e y dy dx should be equal to 0. So when you multiply by dx, you're going to have e y minus 2, yeah, dx plus x e y dy, and this should be equal to 0, implying that our ax our a, this one would imply that our a x1 is equal to e power y minus 2, while our b ax, our bxy should be equal to x e to the power y. Yeah, so we need to see whether they are exact. So curl a, curl y is equal to curl a, curl y, means that we shall differentiate this. Yeah, we first differentiate the power, which is 1, then we rewrite that, so it will keep e to the power y. Then curl b, curl x, now with respect to x, this is 1 times that, so it will be e to the power y. So hence exact. The moment we find that it is exact, now we look at our main function. Our main function is equal to the integral of b. So the integral of b is x e to the power y dy. So when you integrate this with respect to y, still it will be x e to the power y. Then it means that the derivative of the main function x e to the power y should be equaling to 2. Then I will integrate both sides. D dx of x e to the power y dx should be equaling to the integral of 2 dx. When integrate the derivative, you get that very function. So x e to the power 1 should be equal to 2x, then plus a constant of integration. So that is how we work out this. Yeah, all one can stop it there, or one can look for one can say e power y is equal to divided by x. So it will be 2 plus c over x, whichever. So that is it. Now, this is how we solve the exact equations. After the equation being exact, you get the main function. Which main function is the integral of b over the coefficient of dy. Then the derivative of that integral, or the derivative of the main function, should be equal to the right hand side. Now, in case the equation is not exact, you first transform it to exact, and then you continue. First, we must first transform it into exact differential equation, which is done by multiplying an integrating factor, which is our next lesson. See you there.